could have the results of my hard work and intellectual property and thousands of lines of code that I certainly don't want to turn over to anyone on the internet. Might have usernames and passwords to connect to databases or APIs or the like. So probably not good to chmod your code, what? Your PHP code 644, right? So 600, which means only I can read and write it, is probably a better thing. But what does that then mean for the system? That means that the web server has to be able to read my code. But if 600 means only I can read my code, feels like my code is now super secure because not even the web server can serve it up. So how do we mitigate this? Yeah?
The SUPHP module will
Oh, what a wonderful, clever answer.
will run the code as your user.
Good. So we did use in the appliance, we do use on the cloud, and some web hosts, but not many, use something like SUPHP. There's other versions of this, FCGI, FastCGI, and there's a couple of other incarnations of this, but it does exactly that. SU is substitute user, PHP, and all this means is that this is a free module that you can add to Apache or other web server packages that make sure that your code runs as quote-unquote Alice or as Bob, whoever you actually are. So this way, your code cannot do bad things to other people's code. So under this model, if I'm Alice and my code is executing under username Alice, that means my PHP files only need to be chmoded 600 because only Alice needs to read those. And if the web server is pretending to be Alice, then that's perfect. Only Alice has permissions. But if now Alice is trying to be malicious and tries to overwrite files in Bob's account, she won't be able to, right? Because her code's executing as Alice. And so long as Bob hasn't done something stupid, like chmod his file 777, and if you've ever done this, and you know who you are, not the best decision, that means anyone on the system can write to your files. And so all Alice has to do is know or guess some file name. And if your file name is called config.php, and that's where all your usernames and passwords are, it's not going to take Alice all that much time to somehow gain access to all of your files if there weren't this defense of everyone operating under their own username. So actually looking for web hosts that do support this or the equivalent so that your code is only running as you, or you have a dedicated server so that yours is the only code running, is certainly something you should be mindful of. Another alternative, not uncommon years ago, well, if the problem is that you want your files owned by and viewable only by Alice 600, but the server needs to see it, well, a solution here would be to run the server in administrative mode. So have the server be run as root. Okay, it's not done as often anymore, but why is this bad? Probably. Yeah?
Now there's a vulnerability in the server. You're able to access all of the system's files.
Yeah, exactly. Running anything as root is generally a bad thing, right? Because if there is just one bug in Apache or in PHP or whatever tool you're actually using, and some bad guy on the internet figures out how to exploit that, the account that he or she has just exploited is, of course, root, which now means your whole machine is hosed. And this has non-trivial implications. When you detect your machine has been compromised, you can't just like upgrade PHP and say, OK, now I'm safe. You have to assume that every aspect of your machine has been compromised, and you literally want to wipe it and start from scratch. The data you can pull off, but any program, like the login program, the SSH server, the web server, you should assume that now they all have a backdoor of some sort that the bad guy put in there. In fact, years ago, the first way I learned this lesson was I was living after college with some roommates, and we were running our own Linux server for file serving and printers, print serving, and for internet access. And I woke up one morning to print something, and all of a sudden I couldn't print. And this was kind of curious and suspicious, but not worrisome at first. But when I started poking around, I realized that our Linux server no longer had a /var directory. And /var means variable. It means where stuff is changing on a system typically. But in var is /var/spool, which is the mail spool, which is the folder in which files to be printed end up. And there was no var directory anymore. But what else is in the var directory typically on a Linux box? So var www is often there. And what else? Not passwords. Those are usually in etc or /etc or elsewhere. But var/logs. So what this bad guy had done, and to this day I don't know what exploit he or she took advantage of, but their approach to covering their tracks so that I wouldn't notice the machine was compromised was to rmrf/var, and with it all of the logs, and of course with it the ability to print, and so that was our tell. And I wasn't very good at auditing things at the time with special tools and whatnot, so the mere fact that I couldn't print, inability to print should not be your first clue that you've been compromised. So realize that keeping these things in mind can have some real repercussions. All right, so any questions on these sort of lower level details of ownership and things to be mindful of when moving from classroom to real world servers? All right, so this one's fun, if only because it involves this guy. Cookies are sort of this fatal flaw, potentially, in a lot of websites. And we did a fun demo a couple years ago, talked about it in 50 this past year, as to how you can exploit these things called cookies. So in general, all of these lines of text, this represents what? What did I copy and paste here? Yeah, so it's an HTTP header, a set of HTTP headers. And are these from the server or to the server? From. And how do you know? What's the tell?
200 OK.
What's that?
The HTTP at the top, the 200 OK.
Good. So the 200 OK is something a server would say, not something a browser would say. And also a server would say set cookie. A browser would only say cookie. So a couple of clues there. So in bold are a couple of cookie values. The first represents what? Yeah, so it's a session ID. So you know that in PHP and in other languages, you have this notion of stateful information, whereby you have some global variable like $_session in PHP that you can read and write values to. And somehow or other, those values come back to you and are still available to you, the programmer, even after the user has just loaded a page, walked away for 10 minutes, and then clicks on a link and visits some other page entirely, even though the connection, the TCP connection to the server, was broken. So why is this such a long sequence of numbers and characters? Why not just say the session ID is Malan's? Just ask kind of a dumb question. Someone else. OK, yeah.
Because you could just write your own cookie file on your computer and change the value of that one to whoever you wanted.
Right. Right, exactly. You don't want to pick something that's so deterministic and so obviously identifiable that anyone could spoof it quite easily. Even though we take for granted that the browsers are sending these things back and forth, in 1 minute you could write some PHP code that mimics these same headers and then pretends to have any cookie value it wants. This is generally known as session fixation, just fixing the session to be some known value. So this is probably some huge pseudo-random number. And path at the end just means it's valid for foo.com/, so the entire domain, for instance. So this is all kind of a big problem, though, because even though this number is big and pseudo-random, I'm not likely to guess it. But we just saw with Wireshark that I could very easily, within seconds, sniff any one of these session cookies if people are on Facebook or on Gmail or the like, and then present it as my own, potentially, thereby logging in as your account. Firesheep was the tool that came out about a year ago that made this all the more evident to normal people, because it was so easy all of a sudden to do this. So how do you prevent things like Firesheep? How do you prevent random people like me sniffing a cookie, then pretending to have that same cookie so that I effectively can log into whatever website you are currently logged into as well? Thankfully, this one actually has a right answer. Yeah. Yeah, so encryption. So not always, but often, encryption at least is the answer, or at least raises the bar to these kinds of things. So we're all seeing this in the clear. But if you just encrypt all of this information, now only browser and server can see this. And so that actually does prevent this attack. I don't know, has Facebook switched over 100% to SSL, or do you still have to opt in? OK, so that's curious. So at least everyone in this class, frankly, should opt into this feature. And I'm sure it's buried somewhere under settings or whatnot. But if you go home tonight or right now and are playing with Facebook and you see that your URLs are all still http://, not just for login, or not for login, but for everywhere else, go find this option. Because it means all this time your roommate or some random person in Starbucks could trivially be logging into your Facebook account. Gmail's better at this because Google a year ago switched over to SSL as well. Some websites are starting to do this. But why would not every website do this? Yeah?
It's more heavy or they didn't have to do computations.
Yeah, so it's a little more work for the server. If you assume that no cryptography is free, but some cryptography requires some CPU cycles, and you only have a finite number of CPU cycles per unit of time on a server, right? It's 1 gigahertz, 2 gigahertz. If you're going to spend some more of your cycles on encryption, it means you have fewer cycles available for more users. So if you previously supported 100 users, now you might support only fewer than 100 users. Is that reason enough to make all of your users vulnerable to this? No, probably not. And to be honest, in the commercial world, there exist devices called SSL offloaders that you do all the encryption for you, so you don't have to worry about pinching pennies in that way. You just have to buy 1 or 2 such devices. So this is something, too, that frankly, moving forward, all of your sites should operate over SSL. I mean, even the courses, CS50s, all of our stuff, almost all of our stuff now is over SSL because it's so easy to do. And frankly, not until you get to the point of like Facebook and Google and Twitter where you really have to worry about saving every little CPU cycle is this probably a financial issue anyway. All right, what about this other set cookie? This suggests a vulnerability or a poor design decision. What has this developer apparently done? How can you remember that a user has logged in to a website? Poorly, let's say. So you can just plant whatever they typed in.